Hi, I'm here to glaze and chill because I don't know how else to start this video other than glazing and chilling. And if you're an admissions committee and don't know what those words mean, rest assured they are not anything explicit. To glaze is to compliment something heavily, and to chill is to recommend something. The former can be thought of as the concept/entity equivalent of simping. And if you don't know what that means, I beg of you don't look it up. Anyways, I'm going to eat pizza after this video. So if I'm talking really quickly, that's why I want to get this done as quickly as possible. So OpenAlex. This video will be dedicated to some statistics that I gathered from there. OpenAlex is a repository that indexes all the papers which have ever been published and provides a way to access information about these papers through their API. It basically connects all the data you might want to know about a paper in one place, like getting the author's affiliation, where the research was conducted, how it was funded, and all of this is sorted into pretty detailed topics, right? Don't be mistaken though, they don't have the full text of any papers. The actual content is just linked through the DOI, though there is an option to filter for open access papers, which is really cool. And if I say open source instead of open access in this video, that's because I am more of a nerd than you would expect, which is a very high bar, actually. So another cool thing I found out about this project is that they are used to make the data from it is used to make something called influence flowers, which are these little graphs for which authors cite to what, and this is just taken from ArXiv, from a paper published by Microboon as well. And I found OpenAlex just through messing around with ArXiv, and I found our influence flowers. So, unironically, influence flowers and the fact that ArXiv uses them might have saved this entire like Spotify wrapped, physics wrapped type series because I don't know where else I would get statistics. So, thank you. Yeah. Speaking of statistics, I would like to show off some of them just for fun, really, because this video shouldn't be taken too seriously, I think. There's some problems with the metrics that I'm using. Feel free to point them out. This is a little exercise, but no, I will get to them. So, firstly, the top journals by publication count. This shouldn't come as much of a surprise, and this is about to be absolute hell to me because I never learned to pronounce numbers. So, yeah. Elsevier BV, this is Cell and Science Direct. They have 14,836 papers. American Physics Society, that's Physical Review Letters, has 1,300, no, 13,600 papers. The European Organization for Nuclear Research has around like 12,000 papers. IOP Publishing has nearly 9,000 papers. Cornell University, aka ArXiv, right? They're ran by Cornell, have 7,700 papers, almost 7,800, and Springer Nature have 6,800 papers. So close, but yet so far from the funny number for a grand total of 146,381 papers, including all other journals not listed here. I promise I know how to do basic addition. I promise. Yeah, so all right, now I think it would be a bit unfair to leave out the rest of the papers in all the other fields. So let's just torture the high school freshman girls some more without actually providing anything new. What could go wrong? This is the plot of Neon Genesis Evangelion, by the way. Anyways, Elsevier BV with a million papers, followed closely by Springer, aka Nature, with 300,000 papers, Wiley, with 284,000 papers, the Multidisciplinary Digital Publishing Institute, which has a lot of cool open access stuff that you should look up, and it's going to be linked in the description with around 244,000 papers. and the European Organization for Nuclear Research with 244,000 papers as well. And also these journals, Taylor and Francis, which are some UK journals with 135,000 papers, Relks Group from the Netherlands, which is related to Elsevier, but its own separate thing also because of some kind of business thing that I have no clue how to decipher from the Wikipedia page, with around 119,000 papers. I'm rounding on the fly right now, so if my rounding is inconsistent, blame the fact that my brain is inconsistent, okay? Nature Portfolio, which is also Nature, see Springer above, with 94,000 papers, 95 almost thousand papers. La Trobe University with almost 92,000 papers, and Oxford University Press with 91,000 papers for a total of 7,606,256 papers across all fields. Somebody was pinging me in Discord while I was saying all that, and whoever it was is about to get a stern talking to because I could have sworn I enabled Do Not Disturb. But anyways, um, as was mentioned just now when I was talking about Multidisciplinary Digital Publishing Institute, try saying that 4 times fast. It's that open access is pretty chill, right? I'm chill with open access, so I want to highlight some of the journals that went open access this year. These likely won't be all of them because the website, the directory of open access journals that I'm getting this information from, doesn't does take some time to get new information, because it takes time to get the information. But yeah, this might not be all of them. And if you know something that I didn't mention here, then feel free to leave it in the comment and I'll put it in the description, as we're all here to learn, right? If you know something, then you're gonna teach me. If I know something, then I'm gonna try to teach you. Awesome. All right, without further ado, let's do this. So the journals, and I will mess up the pronunciation. Ülkembiyoc Reviews, a Turkish journal focused on biochemistry, climate change, and solving the climate crisis. Information technologies and systems. It also has a Ukrainian name, Ukrainian journal on the development and of application of information technologies. Basic and clinical biochemistry and nutrition, an Iranian journal on biochemistry and nutrition science. And ARC Geophysical Research, a US journal on geoscience and climate change as well. Medicine and biotechnology. Seriously, these people need to get more creative with their names, but I digress. A Russian journal on medicine, biotech, and pharmacology. I apologize for my previous comment. I remembered that this journal has an alternate name in Russian, so it doesn't sound as basic. And Advances in Physiology Education, another US journal that focuses on, well, physiology education. What did you expect from that title? Yeah, that's pretty neat. So I would also talk, I would also like to talk a little bit about IEEE, or IE, if that's how you read it, I guess. I don't know. Or the Institute of Electrical and Electronics Engineers. It's pretty cool. Even though it's not strictly physics, I have been hyping it up for a few videos now, so I'm basically legally obligated to talk about it. This institute supports a lot of cool stuff, and they have many open access journals as well, including a multidisciplinary one, literally called IEEE Access. I apologize. Still haven't said open source though. But including that one, there are 36 journals, all of gold status of open access. And what this means is that anyone can read or do anything with the papers published, but the authors still have to pay some fees in order to get the article published. And If these fees aren't there, then this is called Diamond Open Access. And while I'm not sure if the journals I talked about just now, these ones would qualify for Diamond Open Access because some of them, the authors don't retain full rights. I would wager that they would be considered Diamond Open Access because there are no publishing fees there, and you can verify that on the directory of Open Access Journals website as well. All right. Yeah, you can check these links and they will also be in the description unless I forget, in which case remind me, please. Or you can just copy them from the screen, I guess. All right. Enough shilling, back to shilling for a different cause, aka more OpenAlex statistics. So the top topics of 2025. By a wide margin, we have cosmology and gravitation theories, right? Trying to develop quantum gravity, which is basically the holy grail, though a lot of stuff is lumped into this topic from what I can tell. So perhaps it's a bit of like that as well. Then particle physics theories and experiments. Again, not much of a surprise. Scientists are actively trying to work out improvements to the standard model or the best theory that we have of particle physics, and that falls under there. Um, the next thing is crucial, however, and it's this neural network research that gets lumped into physics because that's kind of what physics does on a theoretical level. It works with and analyzes complex systems. So as I mentioned in the Nobel Prize video, this isn't really something to be surprised or, I guess, concerned about. It's pretty neat, actually, that what we as humanity have developed can also be so applicable in so many places. Then there's astronomy stuff, broadly speaking. Black holes and all of theoretical physics gets lumped in there as well. And I'm joking, of course, theoretical physics is a broad field. And lastly, quantum mechanics. Read these numbers yourself, honestly. Okay, fine. Cosmology and gravitation theories, 6,333 papers. Particle physics, theoretical and experimental studies, 3,694 papers. Model reduction and neural networks with 3,611 papers. Stellar, planetary, and galactic studies with 3,494 papers. Black holes and theoretical physics with 3,338 papers, quantum mechanics and applications with 3,298 papers. Trust me, I wouldn't be doing that unless it was an accessibility thing. All right, now time to get real and get serious. For the next section, I would just like to say that it's not the amount of papers that something publishes or that are published in a specific domain or crucially funded by a specific funder. It's more the quality of these papers. And of course, I don't want to say that because I'm not qualified to, that that a whole class of papers is like low quality or something. But nonetheless, it's important to see that this quantity over quality mentality is prevalent in academia more broadly right now. It really only takes a few papers to make all the difference, and that won't exactly show through in these statistics. Even Microboon, right? They get a ton of money because running all these fancy accelerators and detectors and cooling systems costs money, but they don't publish that many papers, which I saw when I was getting the influence flower, right? I was looking at the papers published by the Microboon collaboration on ArcSiv. I'm only now remembering that ArcSiv is supposed to be pronounced archive because the X is a Greek letter chi, but you know what? ArcSiv identifies it better than just archive, so we're running with it. Yeah. And like I'm so hung up on Microboon because the research they do truly matters and because like they made, I'd argue, I dare to argue, right, one of the most important particle physics discoveries of 2025. And nonetheless, I need to pad out this video somehow, so have some numbers as a treat. Right. The top funders of 2025, the National Natural Science Foundation of China. I promise I know how to read. This is the language that I'm literally the most proficient at. Please let me have this. 9,662 papers. The National Key Research and Development Program of China with 2,531 papers. Again, really tiny margins here, don't you think? Did I do that sarcasm thing right? The National Science Foundation, which is the US National Science Foundation, because the US is the default, clearly. No other countries exist. Duh. Yeah, with 2,456 papers. The Deutsche Forschungsgemeinschaft, or the German Research Foundation, with 1,796 papers. The U.S. Department of Energy with 1,761 papers, and the Japan Society for the Promotion of Science with 1,546 papers. Again, I would like to remind you that these are fundings. Fundings. Awesome use of the English language. Congratulations. So I was originally going to also include a section on the top authors of 2025, but that's not happening. Top authors by paper count published were publishing way more than should, I guess, be possible. I won't say could, but like should be possible. And I can't really tell if they have a point because I don't know physics at that level, and I'm inclined to give people who are smarter than me the benefit of the doubt. Also, the top two authors only collaborate with each other, which isn't inherently a bad thing, I guess. Also, two out of these top three researchers are also independent, which nothing against them, but I just don't feel confident enough to report on these statistics if I'm not able to verify they're actually doing good. And I can't speak or really have an informed opinion on independent researchers because, I mean, look at me. Do I look like I can? No, I look like I listen to nightcore versions of Mitski songs at like 1 a.m., which is probably a self call out, but I'm not gonna comment on that any further. And I don't really have the experience with academia to comment on anything relating to these authors at all, right? So that's my 2 cents. Let's not dwell on this and let's not harass anyone. If you figure out who these people are, okay, it's just numbers and I'm just saying things. Please be nice. I can't afford legal fees. All right. Finally, I like to show off the papers which have been cited the most this year. Note that that's not the best metric I could have picked. Arguably a terrible metric, as I have written here, considering there's no way to programmatically measure impact. Citations is just the closest I feel like I could get to considering the format, right? But a fatal flaw is many papers which were published later in the year won't make it into this video simply because they haven't had the time to be cited enough to make it into the like top 6 most cited on OpenAlex, right? I'm going to be including 6 papers. And as you'll see, all of this research I'll be showing was from the first quarter of 2025. However, I do believe this metric has some merit to it. The most cited to means the more it's cited means the more it's being elaborated on and things are being developed from any given paper. But with that out of the way, here we go. The first two, spin polarization of an expanding and rotating system published by the Physical Review Letters D. on 14th of April 2025 by Nora Wakegenant and John Paul Blazeau. The stochastic Scoville-Schulz-Dubois machine and its three types of cycles, published in Physical Review Letters E on the 3rd of January 2025. So the anniversary is coming up, by Fei Liu and Jiaying Gu. The second two is optical properties of quasi two-dimensional GAAs slash AI GAAs. Oh no. Oh wait, these are chemical compounds. I don't have the periodic table memorized. Hold on. Hold your horses. Hold your horse, girls, and your horses. I'm gonna look up the periodic table real quick. Like, I'm fairly confident, but I don't want to embarrass myself, which you could argue I'm embarrassing myself by admitting that I'm not 100% confident. But you know what? Sometimes that's just what you have to do in science, and none of these periodic tables have the full name listed. I'm so cooked. And okay, this is good enough. Gallium. Yeah, I was fairly sure about gallium, considering I read a paper on the gallium anomaly, which probably didn't even mention the symbol for gallium, but you know what? We kind of have to take what we can get because winners can't be choosers. Yeah, gallium arsenic slash aluminium gallium arsenic nanosheets prepared by releasing epitaxial layer. What is an epitaxial layer? Hold on. We are here to learn. Epitaxial layer. We are here to learn. Is a type of crystal growth or material deposition in which new crystalline layers are formed with one or more well-defined orientations with respect to the crystalline seed layer. The deposited crystalline film is called an epitaxial layer or epitaxial film. Quasi two-dimensional, okay. That's pretty neat. So they peel off this epitaxial layer to get these nanosheets that are so thin that they're almost two-dimensional. That's pretty neat, if I'm reading that correctly. All right, published by these people: Bo Zhang, Yu Hao, Chao Shi, Shuang Pu, Xiaohua Wang, Denghui Wang, Dan Fang, Hao Yan, Jihua Li, and Xuan Fang on the 6th of February 2025. Yes. On the 6th of February 2025, a prototype of high beam SCE, a real-time high-resolution single-event effects locating device for heavy ion facilities. Ooh, that's actually cool. Published by IEEE. Oh, and the previous paper was published by IOP Publishing, by the way. By Jianwei Liao, Yanhua Jia, Shun Liao, Jiang Yongdu, Hao Boyang, and Zhu Huang on a day. Certainly a day. Hold on. No. Oh, I still have the original OpenAlex query. Yeah, published on the 23rd of January, 2025. All right. That's neat. And the third two, hunting for sources of variability in laser proton acceleration with thin foils, published by all of these people. I don't think I'm gonna read all their names out loud. I apologize. I will put the links to all these papers in the description if you're curious, by the way. Published in I forgot how to read it. AIP Publishing, Physics of Plasmas, on the 2nd of April 2025. And lastly, towards optimization of a sub-terahertz spaceborne VLBI mission by Ben Hudson, Leonid I. Gurvitz, Daniel Palumbo, Sarah Isaun, I'm so sorry, and Hannah Reyna, in Science Direct on, I need to start taking better screenshots, published on the 6th of April. That's pretty neat. So, as you will notice, cool thing here is that 5 out of 6 of these papers are open access. That's really neat, right? These two, the first two, this one isn't the gallium arsenic one from what I can tell. Well, I don't have access to it at least, so it's not open access. The prototype for high beam SCE paper is open access, and then these two are as well. That's pretty neat. So, yeah. And a partridge in a pear tree. One partridge in one pear tree specifically. You probably can't see this, so I'll zoom in for you. Thanks for sticking around through this mini series and through the last year. I hope you will stick around with me for another year and have a good this number, which I will not read aloud because I don't know how to. I had to get Python to calculate it for me because it's so big. But it is 2026 factorial. Have a good 2026 because you would be underestimating me if you thought I wouldn't make the factorial and exclamation mark joke. So, yeah, thank you. Happy New Year once again, and see you someday. See you in the next one.